7.5 goes over even more equations. With these, we're going to be using identities also. So if you look at example 1, we have the equation 1 plus sine theta is equal to 2 cosine squared theta. If we use our identities, if we think about sine squared theta plus cosine squared theta is equal to 1, we can actually replace this cosine squared theta with 1 minus sine squared theta. So if we do that to start, we're going to have 1 plus sine theta is equal to 2 times 1 minus sine squared theta. From here, you're going to want to distribute that 2 in. So this is going to give us 1 plus sine theta is equal to 2 minus 2 sine squared theta. You want everything on the same side of this equal sign, and you want your equation equal to 0. So with this, I'm going to move the 2 over by subtracting it first. This gives us sine theta minus 1 is equal to negative 2 sine squared theta. From here, we're just going to add the 2 sine squared theta to both sides. Be careful, because that 2 sine squared theta and that sine theta are not like terms, so they do not combine. In order for them to have like or be like terms, they have to have the same exponent on them, and they don't. So this is just 2 sine squared theta plus sine theta minus 1 is equal to 0. If you want sine is equal to y, if you want to switch out that sine squared theta and that sine theta for y to make your life a little bit easier to look at this, you can do that. It would just give you 2y squared plus y minus 1 is equal to 0. You know how to factor this, and it looks a lot easier to do opposed to that sine squared theta and that sine theta. So factor this. 2 times negative 1 gives us negative 2. Your factors of negative 2 that add up to positive 1 are a negative 1 and a positive 2. So we replace, and we have 2y squared minus y plus 2y minus 1 is equal to 0. From here, since we have 4 terms, we can factor by grouping. We're going to factor out a y from the first set of parentheses. We're going to factor out a positive 1 from the second. So it gives us y times 2y minus 1 plus 1 times 2y minus 1 is equal to 0. From here, we're going to have 2y minus 1 times y plus 1 is equal to 0. We set both of these equal to 0, and we solve for both. For the first one, we're going to add the 1 to both sides. We get 2y is equal to 1. Then we divide each side by 2. And we get that y is 1/2. For the second one, we just subtract the 1 from each side. We get that y is equal to negative 1. So from here, look at your unit circle. Where is y 1/2 and where is y negative 1? Y is that 1/2 at 5 pi over 6 and at pi over 6. And we also are looking at where y is negative 1, which is at 3 pi over 2. So all 3 of these are our answers. We have pi over 6, 5 pi over 6, and 3 pi over 2 that are our solutions. Our next example, we have cosine theta plus 1 is equal to sine theta. Don't worry about the interval. So that part you can actually cross out. So you can cross out the interval. Don't worry about that. Just solve it. So we're working with cosine theta plus 1 is equal to sine theta. You can't do anything with this other than square both sides. if that sine theta was squared, you could turn it into a cosine squared theta using your identities. So start this one by squaring both sides. This gives us cosine theta plus 1 times cosine theta plus 1 is equal to sine squared theta. That cosine theta plus 1 times cosine theta plus 1, FOIL it. This is going to leave you with cosine squared theta plus 2 cosine theta plus 1 is equal to sine squared theta. Think about your identities again. If we have sine squared theta plus cosine squared theta is equal to 1, and we want to solve that for sine squared theta, subtract over that cosine squared theta, so our sine squared theta is equal to 1 minus cosine squared theta. Replace that sine squared theta with that 1 minus cosine squared theta. So this is going to give us cosine squared theta plus 2 cosine theta plus 1 is equal to 1 minus cosine squared theta. Subtract the 1 from each side, add the cosine squared theta to both sides. These are going to cancel out. The 1 also cancels out. So we're left with 2 cosine squared theta plus 2 cosine theta is equal to 0. Remember, cosine is x. If cosine is x, you can rewrite this as 2x squared plus 2x is equal to 0. This makes things a lot easier to look at in order to factor. Both terms have a 2x. So factor out a 2x from both of them. This is going to leave us with 2x times x plus 1 is equal to 0. Set them both equal to 0. We have 2x is equal to 0 and x plus 1 is equal to 0. Divide each side by the 2 to get x by itself. You get that x is equal to 0. Subtract each side by 1 to get x by itself. You get that x is also equal to negative 1. Look at your unit circle. Where is x 0? Where is x negative 1? X is at 0 at pi over 2 and at 3 pi over 2. X is negative 1 at pi. So use these. You have pi over 2, pi, and 3 pi over 2. For our next set of examples, we are going to be finding the solutions of these equations. When we're doing this, you can forget about the interval. Don't worry about that. For example, 5a or 5, you're just finding the solutions of 2 sine 3 theta minus 1 is equal to 0. So these equations differ because you have a number that's attached to theta with the original equation. For this one, you're going to isolate the sine 3 theta. So move the 1 over to start, add it to both sides. You have 2 sine 3 theta is equal to 1. Then divide each side by the 2. So you get sine 3 theta is equal to 1/2. Find where sine is 1/2 using your unit circle. That means that your y value is 1/2. So you have 5 pi over 6. You have pi over 6. Use both of them. That's going to cancel out that sine, and you're going to just have, and that 1/2, you're going to have 3 theta is equal to pi over 6, and 3 theta is equal to 5 pi over 6. From here, we're going to get rid of that 3 next to theta just to isolate the theta. It's being multiplied, so divide each side by the 3, or 3 over 1. Remember, when you're dividing fractions, you keep, change, flip. So theta is equal to pi over 6 times 1 over 3, as well as theta is equal to 5 pi over 6 times 1 over 3. Multiply straight across for both of these, and you get that theta is pi over 18, as well as theta is 5 pi over 18. For your last example, again, we're not going to worry about the intervals. We're just finding the solutions to the equation square root 3 tangent theta over 2 minus 1 is equal to 0. So I'm just going to rewrite this. Square root 3 tangent theta over 2 minus 1 is equal to 0. Again, I want that tangent theta over 2 by itself. So first thing I'm going to do is add the 1 to both sides. This gives us the square root of 3 tangent theta over 2 is equal to 1. From there, divide each side by the square root of 3. Remember to rationalize your denominator. If you rationalize your denominator, you're going to multiply the square root of 3 by the top and the bottom of that fraction to give yourself tangent theta over 2 is equal to the square root of 3 over 3. Your whole idea is to find, using the unit circle, find where tangent is square root 3 over 3. Meaning, you need to have both the same signs. So if you use that square root of 3 over 2, comma 1/2, and divide them, 1/2 times, take the reciprocal, 2 over the square root of 3. If you rationalize your denominator, it's going to give you the square root of 3 over 3. So you're going to use that pi over 6. You're going to use that 7 pi over 6 because you're going to get the square root of 3 over 3 if you divide your y by your x. So use both of those, pi over 6, 7 pi over 6. So theta over 2 is equal to pi over 6. Theta over 2 is equal to 7 pi over 6. Get rid of the 2 that's underneath theta to where you just have theta. Multiply each side by 2 for both of these equations. It's going to cancel out the 2 on the left side. On the right side, you can simplify the 2 and the 6. The 2 becomes 1. 6 becomes 3. So theta is equal to pi over 3. Same thing with your other equation. Theta is equal to 7 pi over 3.